We're looking at the chapter review, chapter 4, problem number 10. What we want to do here is we want to identify the probability distribution and then answer the questions based off that distribution. We also want to know if any of the events are unusual. Remember, unusual events have a probability of less than 0.05. So the question is, 51% of U.S. adults oppose hydraulic fracturing, also known as fracking, as a means of increasing the production of natural gas and oil in the United States. You randomly select 5 U.S. adults. Find the probability of U.S. adults who oppose fracking as a means of increasing the production of natural gas and oil in the United States is exactly 2, less than 4, and at least 3. So what we want to do is when we look at this, we notice that we have a chance of success. That 51% of U.S. adults is a chance of success, right? 51% of we grab in will oppose fracking. We have a chance of success, and that will be the same no matter what we draw for everyone we picked. Now we pick 5 people, which means we limit the number of trials. Well, this meets everything we need for a binomial distribution. So let's get our variables written over here. So we have a success value of 51%, or 0.51, which means we have a failure value of 0.49. We're picking 5 adults randomly, so that's the number of trials we're doing for our binomial distribution. And we want to know, for part A, what's the probability of exactly 2? For part B, we want the probability of less than 4. And for part C, we want the probability of at least 3. So at least 3 or greater. So what we can do is with our binomial distribution is we have a couple of options. We can use the table in the book, but that only does our percentages by 0.05, and we have a 0.01% here with the 51%. Or we can use our technology to work out our binomial distribution and put them together. So on our TI-30s, our formula for the binomial distribution is going to be NCX P to the X times Q to the N minus X. So once we enter this in once on the calculator, we can use our up arrows to get all of the probabilities that we need. Now there are a total of 6 probabilities that will come through here. P0, P1, P2, P3, P4, P5, and P6. So let's start by generating those probabilities. So P0 on the calculator would be 5, choose 0, 0.51 to the 0th power times 0.49 to the 5th power. So to do that, the keys you would hit, you'd hit 5, you'd hit the probability key, then you'd hit the arrow over until you got to NCR, you'd hit enter and 0, then you would multiply by 0.51 to the caret 0, multiply 0.49 the caret 5. And we can repeat this for each probability. So I'm going to do this to work out our probabilities for us here. So the probability of this being 0, where's my TI-30? So second is binomial, and we have 5.51, 0, and so our probability of 0 0.0282, 1, 2, 3, 4. I'm going to take it to 5 decimal places. And I'm going to continue building the table of values until I have all 5 probabilities. So the probability of 1, I'm going to hit my up arrow key. And I'm going to do 1, I'm going to do 5, NCR. I'm going to replace this with a 1, this with a 1, and that with a 4 as I work my way through my equation. So up arrow, 1, and I get 0.14700. My probability of 2. Again, I'm going to up arrow. I'm going to replace this now with a 2, this with a 2, and that with a 3. And I get 0.306001. Sorry, I'm keeping it to 5 decimal places ahead around there. Again, up arrow, I'm going to replace this with the 3, this with a 3, and this with a 2. And I get 0.31850. And let's see, we'll put P4 here. So I'm going to do 4. So I'm going to up arrow, replace this with a 4, this with a 4, this with a 1, and get 0.16575. And the last probability we'll need to figure out this distribution, I replace this with a 5, this with a 5, and this with a 0. And I get 0.03450. And so I have my probability distribution for the likelihood of the events happening here. And so for A, for the probability of it being exactly equal to 2, I look at the chart of values that I just made, and let's see, and I get exactly to 0.30601. And the book is saying, hey, we want 3 decimal places. So this will be 0.306. Now for the probability of P being less than 4, right, I need to add the probabilities that come before 4. So I need to add these 4 probabilities here. So 0.02825 plus 0.14700 plus 0.30601 plus 0.31850. Right, so I'm adding, I'll highlight them in yellow or green. I'm adding these probabilities because these are all the probabilities that are less than 4. And I get 0. They want 3 decimal places. So get 7999976 or 0.800. And lastly, I want everything greater than 3, greater than or equal to 3, and that's the sum of these 3 probabilities. So the probabilities for x greater than or equal to 3 are the sum of the last 3 probabilities on my distribution. And I get 519. 0519. And none of these events are unusual because none of them are less than 0.05. And so this is how we can use the Poisson distribution. What's I think nice about the Poisson distribution compared to our binomial distribution, this is binomial. What is nice about the binomial compared to the Poisson is it has a limited number of trials. I can write out everything. The Poisson, which I want to compare it to, has an infinite number of trials. And so we have to play with complement space to find things on it. Where here, I can write down all the values I need and sum them up.